There is a planet in this solar system that does not tolerate visitors. It does not warn you. It does not negotiate. It simply begins the process of dissolution the moment you enter its domain. The process is not metaphorical. It is electromagnetic. It is total. It is, by any technical measure, a form of execution. The planet is Jupiter. You already know it is large. You have seen the photographs, the banded atmosphere, the red storm that has persisted for centuries. These things are true, and they are irrelevant. What matters is not what Jupiter looks like. What matters is what Jupiter does to anything that tries to observe it. Jupiter is the most powerful magnetic object in the solar system that is not a stellar body. Its magnetosphere extends outward approximately 5 million kilometers in the direction facing the Sun. On the opposite side, the magneto-tail, it stretches past the orbit of Saturn. This is not a protective envelope. This is not a shield. This is a jurisdiction. This is the boundary of Jupiter's authority over matter and energy, and everything that crosses it becomes subject to processes that were not designed with human technology in mind. The numbers are not dramatic. They do not need to be. Earth's magnetic field has an average surface strength of approximately 25 to 65 microteslas. Jupiter's surface magnetic field averages approximately 417 microteslas at the equator. At certain poles, it exceeds 2,000 microteslas. The magnetosphere of Jupiter is roughly 20,000 times more energetic than Earth's in terms of total particle energy content. It traps and accelerates charged particles in a way that has no analog in any terrestrial environment. You cannot feel a magnetic field. This is the first deception. You approach Jupiter in your spacecraft, and the instruments continue to return data, and the solar panels continue to function, and the CPU continues to execute its instruction set, and you do not feel anything at all. You do not feel the electrons threading through your shielding. You do not feel the protons embedding themselves in your circuit traces. You do not feel the radiation-induced charge accumulation building inside your silicon junctions like a silent tide. And then you feel all of it at once. Not you, your instruments. The distinction matters less than you think. Jupiter does not look at you. Looking implies passivity, implies observation from a distance. Jupiter invades. From the moment your probe crosses the bow shock, the outer boundary where the solar wind first collides with the magnetospheric field, Jupiter has already begun to interact with your hardware. The interaction is not optional. It is not selective. Every charged particle in the radiation environment is governed by Lorentz forces, and those forces do not distinguish between an intended trajectory and an unintended transit through your memory array. This is a system of control. You have entered it. You will not leave it unchanged. A radiation belt is not simply a region of space that contains particles. A radiation belt is a machine. Earth has two radiation belts, the Van Allen belts. They were discovered in 1958. They contain energetic protons and electrons trapped by Earth's magnetic field, and they represent a radiation hazard for satellites in the wrong orbital bands. Engineers plan around them. They are a known quantity. They are manageable. Jupiter's radiation belts are not manageable. Jupiter has radiation belts that make the Van Allen belts appear to be background noise. The inner belt, the primary zone of maximum intensity, begins at approximately 1.5 Jovian radii from the planet's center. A Jovian radius is approximately 71,492 kilometers. Do the arithmetic. This region of maximum radiation intensity begins less than 36,000 kilometers above Jupiter's cloud tops. It is extremely close. It is extremely lethal. The mechanism is synchrotron radiation and adiabatic acceleration. Charged particles, primarily electrons and protons, with contributions from sulfur and oxygen ions, are trapped along the magnetic field lines and undergo a process called gradient and curvature drift. They spiral. They bounce back and forth between the magnetic mirror points near Jupiter's poles. They drift azimuthally around the planet. This motion, this trapped oscillating trajectory, is not static. The particles are continuously being energized by variations in the magnetic field, by interactions with plasma waves, by the centrifugal pump effect of Jupiter's rapid rotation. Jupiter rotates once every approximately 9.9 hours. This is fast. For a planet with an equatorial diameter of 142,984 kilometers, this is extraordinarily fast. The rotation drags the magnetosphere. The magnetosphere drags the plasma. The plasma accelerates. The electrons in the inner belt reach energies measured in tens of millions of electron volts. Tens of millions of electron volts. For comparison, a dental X-ray operates in the range of roughly 50,000 to 80,000 electron volts. The electrons in Jupiter's inner radiation belt carry energies hundreds of times greater. These are not thermal electrons. These are not solar wind electrons. These are particles that have been continuously processed by one of the most efficient natural particle accelerators in the solar system, operated around the clock by the rotational energy of a gas giant with a mass of 1.898 × 10 to the 27th kilograms. These electrons move at relativistic speeds. Relativistic, not fast, not very fast. Relativistic, meaning a measurable fraction of the speed of light. The inner belt electrons approach 0.99 C in some measurements. These are not particles that bounce off your shielding. These are particles that pass through your shielding as though it does not exist, depositing energy along the way, stripping electrons from atoms, ionizing material, breaking chemical bonds, disrupting crystalline lattice structures in your semiconductor devices. The dose rate in the inner belt is not a number you can intuitively comprehend. Estimates from Juno mission data suggest that a probe operating in the highest intensity regions without shielding would receive on the order of millions of rads per day. The LD50 for an unshielded human being, the dose at which 50% of exposed individuals die within 30 days, is approximately 400 to 500 rads. Jupiter's inner belt delivers that dose in seconds. The particle flux at the inner belt peak is approximately 10 to the 8th electrons per square centimeter per second at energies above 20 MeV. This is not a hazardous environment. This is a systematic elimination process. The word for this is not hostile. Hostile implies agency, implies intention. Jupiter has no intention. This is more absolute than intention. This is physics. Physics does not negotiate. Consider a memory cell, a single transistor in a DRAM array. It stores one bit, one binary value, 0 or 1, on or off. The distinction is maintained by a charge, a small number of electrons held in a capacitance junction, the presence or absence of which determines the logical state. This is the foundational unit of all computation. Everything your spacecraft knows, its orbital position, its command queue, its scientific data, its operating system, exists as an aggregate of these states, billions of them, arrayed across your memory chips in a precise, carefully maintained configuration. Now, introduce a high-energy particle. The particle, an electron at 50 MeV, say, entering through your radiation vault, passes through the silicon of your memory array. As it transits, it deposits energy. It ionizes the material along its path. It generates a track of electron hole pairs. If this track passes close enough to a storage cell, the generated charge may be sufficient to flip the logical state of that cell. A 1 becomes a 0 becomes a 1. The stored value changes. This is called a single event upset, a bit flip. The bit flip is silent. It produces no error message. It generates no flag in the hardware register. The memory cell has simply changed its value, and the system does not know. The system cannot know, not without dedicated error detection circuitry, and even that circuitry is subject to the same particle flux. One bit flip is a glitch, an annoyance, something a robust system can absorb. At 10 million rads, you are not absorbing glitches, you are accumulating systemic damage. The errors multiply. Bit flips stack. Logic gates, the fundamental switching elements of your CPU, begin to exhibit incorrect behavior. An AND gate that should output 0 outputs 1. An adder that should compute a sum computes a different sum. An instruction register that should contain a jump command contains a halt command, or a command that does not exist, or a command that does something else entirely. The CPU begins to lie. This is not metaphor. The processor is executing instructions, returning results, maintaining the appearance of normal operation. But the instructions it is executing are corrupted. The results it is returning are wrong. The stored program it is running is not the program that was uploaded. It is a degraded approximation of that program, randomized in proportion to the accumulated dose. The Galileo spacecraft, which operated in Jupiter orbit from 1995 to 2003, was designed with substantial radiation hardening. It accumulated an estimated total dose of approximately 650,000 rads over its mission lifetime, a figure that would have destroyed unprotected consumer electronics in minutes. The spacecraft survived, but it required careful mission planning to minimize radiation exposure, and the degradation was continuous and measurable. The Juno spacecraft, currently operating in Jupiter orbit, receives an estimated 20 megarads of total dose per mission, roughly the equivalent of 100 million dental X-rays. It is protected by a radiation vault containing its most sensitive electronics, a titanium box with walls 1 centimeter thick. The vault reduces the internal dose by a factor of approximately 800. And yet, Juno still degrades. The degradation is slower. It is not prevented. Consider what 10 million rads does to an unshielded circuit board. The gate oxide layers in your transistors accumulate trapped charge. The threshold voltage of your transistors shifts. What was once a reliable switching element becomes unreliable. Timing errors propagate through your logic chains. Instructions execute in wrong sequences. The system begins to exhibit behaviors that were not programmed, not in a functional sense, but in a mechanical sense, in the sense that the hardware is producing outputs that do not correspond to its intended design. There is a term from computational theory for a system that returns incorrect outputs while maintaining the appearance of functionality. A Byzantine fault. The system is still running. The system is still sending telemetry, but the telemetry is wrong. The science data is wrong. The health reports are wrong. The probe believes it is performing nominal operations. It is not. Its beliefs are the product of corrupted memory addressing corrupted instructions in a corrupted processor. This is electronic psychosis, precisely defined, clinically described. It is not chaos. It is deterministic degradation, the predictable outcome of silicon under extreme particle bombardment, producing outputs that appear meaningful and are not. Assume your probe has survived to this point. Assume the radiation has not yet crossed the threshold of total computational failure. Assume the CPU is still executing something recognizable as its original program. Assume it has data, scientific data, magnetometer readings, particle detector counts, spectroscopic measurements, data that cost billions of dollars and years of trajectory planning to acquire. Now transmit that data. The probe's radio system operates in the X-band or K-band, frequencies in the range of 8 to 32 gigahertz. The transmitter generates a coherent electromagnetic signal, modulates it with the encoded data, and radiates it outward through the high-gain antenna in the direction of Earth. The signal must then propagate through the Jovian magnetosphere. The magnetosphere is not transparent to radio waves. It is a plasma, a soup of charged particles, electrons and ions, with a characteristic frequency called the plasma frequency. Below the plasma frequency, electromagnetic waves cannot propagate. They are reflected, or they are absorbed, or they are refracted into trajectories that no longer point at Earth. The plasma frequency in the Io plasma torus region reaches values on the order of tens of megahertz, below the transmission frequencies of most spacecraft, so the signal can in principle escape. But escaping is not the same as arriving coherently. The signal traverses a medium of varying electron density. Regions of higher electron density slow the phase velocity of the wave. Regions of lower electron density allow it to propagate faster. The result is dispersion, different frequency components of the signal arriving at slightly different times. This is not catastrophic for most signals. It is manageable. It is a known correction applied by ground stations. But the Jovian magnetosphere is not static. It rotates with the planet. It is turbulent. Plasma density fluctuations on timescales of seconds to minutes create a dynamic refractive index that varies across the antenna beam. The signal scintillates, it flickers, it fades in and out as the plasma structures between the probe and Earth shift and rotate. And then there is the background noise. Jupiter is the most powerful natural radio source in the solar system outside the Sun. It emits broadband radio noise, synchrotron radiation from the radiation belt electrons spiraling along field lines across a wide range of frequencies. This emission is continuous, unpolarized, and covers much of the spectrum your probe is trying to use. The signal-to-noise ratio for a probe deep in the Jovian system attempting to transmit to Earth is not favorable. It is not simply unfavorable. At certain geometries, at certain orbital phases, the background emission from Jupiter itself threatens to overwhelm the probe's transmitter output. The probe is trying to shout. Jupiter is already shouting louder. There is additionally the question of occultation. Jupiter is large. There will be periods, predictable, unavoidable, during which the probe is on the far side of the planet relative to Earth. No signal. The data accumulated during those periods must be stored and transmitted during the brief windows of line-of-sight contact. Those windows are the only moments the probe can communicate. Every bit transmitted in those windows is precious because the next window may not come, not if by then the radiation has finished its work on the transmitter electronics. The Galileo probe's atmospheric entry capsule, which descended into Jupiter's atmosphere in 1995, transmitted data for 57.6 minutes before the signal ceased. Cessation was due to the probe's destruction by pressure and temperature as it descended deeper into the atmosphere. But the clock was always running on a second mechanism, the radiation dose accumulated during the descent profile. The electronics were dying. The transmission was a race between the probe's depth and the probe's integrity, and the outcome was predetermined. The probe was always going to stop transmitting. The only variable was when. This is censorship, not political, not intentional, physical censorship. the erasure of information through the environment through which it must pass. Jupiter does not want to be known. The obvious solution to radiation is shielding. Place dense material between the electronics and the radiation environment. The particles lose energy as they traverse the material. Enough material and the particles that reach the protected electronics carry insufficient energy to cause damage. This logic is correct in principle. It is incorrect in practice, for Jupiter specifically, and the reasons are instructive. The first problem is secondary radiation. High-energy electrons, upon entering a dense shielding material, produce bremsstrahlung, braking radiation, as they decelerate. This is X-ray emission. You have converted a high-energy electron beam into an X-ray beam, and X-rays are photons, which penetrate matter differently than electrons. The shield that slows the electrons generates a new radiation type inside itself. For certain shielding materials and certain electron energies, the dose behind the shield can actually be higher than the dose in front of it for electrons in the relevant energy range. Adding more shielding of the wrong material increases the problem. The optimal shielding material for high-energy electrons is not lead. It is low-Z material, low atomic number materials like water, polyethylene, aluminum, because low-Z materials have a lower bremsstrahlung yield. A multi-layer shield combining low-Z outer material with higher Z inner material is more effective than a simple lead block. This is known. This is engineered. Juno's vault uses tantalum-lined titanium for this reason. The second problem is mass. Every kilogram of shielding is a kilogram not available for science instruments, propellant, structural components, communication systems. A spacecraft is a mass budget problem. Every design decision trades one requirement against another. The radiation vault on Juno masses approximately 180 kilograms for a protection factor of 800. To achieve a protection factor of 8,000, a single additional order of magnitude would require not 1,800 kilograms, but significantly more due to the exponential nature of dose attenuation. The relationship between shielding mass and dose reduction is not linear. The rocket equation is unforgiving. At some point, the shield is heavier than the spacecraft it is protecting, and you have built a radiation-hardened brick that cannot reach Jupiter. The third problem is time. Even with optimal shielding, the electronics inside the vault accumulate dose. The rate is reduced, but it is not zero. It is never zero. Electrons above a certain threshold energy will penetrate any practical shielding. The inner belt of Jupiter contains electrons at those energies in abundance. The vault buys time. It buys months, perhaps a few years of operational life before the total dose inside the vault crosses the failure threshold for the most sensitive components. This is the fundamental truth of the lead shield fallacy. Shielding is a delay, not a solution. It is a slower execution, not a commutation. Juno was designed for a mission lifetime of 37 orbits, originally planned over approximately 20 months. Its orbit was designed specifically to minimize time in the inner belt, quickly passing through the inner belt at close approach and spending most of its time in the outer solar system. The spacecraft skims the edge of the kill zone and retreats. Even so, by the end of its mission, the accumulated dose has caused measurable degradation to its instruments and electronics. Every orbit is a transaction. You trade hardware integrity for data. The exchange rate is fixed by physics and cannot be negotiated. There is a final irony in the shielding problem. The best way to protect electronics from Jupiter's radiation environment is not to bring them to Jupiter. The only electronics that survive the inner belt indefinitely are the ones that never entered it. Every probe we have sent has been, from the moment of its design, a temporary visitor. The question was never whether it would be destroyed. The question was only how much data it could return before the destruction was complete. Jupiter does not generate its radiation environment alone. It has an accomplice. Io is the innermost of Jupiter's 4 Galilean moons, the largest natural satellite system in the solar system. It orbits Jupiter at a distance of approximately 421,700 kilometers, with an orbital period of 1.77 Earth days. It is the most volcanically active body in the solar system. Its surface is covered in sulfur dioxide frost, silicate rock, and approximately 400 active or recently active volcanic features. Its interior is continuously heated by tidal flexing, the gravitational kneading produced by the competing tidal forces of Jupiter and the other Galilean moons. Io erupts continuously. At any given moment, multiple volcanic plumes are ejecting material into space. That material, primarily sulfur dioxide, sulfur atoms, oxygen atoms, is ejected at velocities sufficient to escape Io's gravity. It enters the space around Io, and then Jupiter takes over. The ionized sulfur and oxygen atoms, sulfur ions S+, S2+, S3+, S4+, oxygen ions O+, O2+, are picked up by Jupiter's co-rotating magnetic field and accelerated. They are dragged into a torus, a donut-shaped plasma structure centered on Io's orbital plane. This structure is called the Io plasma torus. The torus extends from approximately 5 to 7 Jovian radii from the planet. It is cold by plasma physics standards, perhaps 50,000 to 100,000 Kelvin for the thermal electron population, but its density is high for a magnetospheric plasma, approximately 2,000 to 3,000 electrons per cubic centimeter at the inner edge. It glows. It is visible from Earth with sufficiently sensitive ultraviolet instruments. It emits approximately 2 terawatts of power in the UV alone. This is the feedback loop. Io erupts. The eruption feeds the plasma torus. The plasma torus loads the Jovian magnetosphere with additional mass and charge. This mass loading changes the dynamics of the magnetosphere. It loads the field lines. It alters the wave environment. It contributes to the processes that accelerate electrons in the inner radiation belt. The radiation belts are partly powered by the continuous volcanic output of a moon that cannot stop erupting because Jupiter's gravity will not let it stop. The tidal heating that drives Io's volcanism comes from Jupiter. The volcanic output fuels the plasma that feeds Jupiter's radiation environment. The radiation environment is partly responsible for the particle fluxes that make Io's orbit so inhospitable. This is a closed system, a machine that feeds itself. For a probe attempting to reach Jupiter's inner system, the Io plasma torus is an additional obstacle. Crossing it means transiting through a region of elevated plasma density and wave activity. The waves, ion cyclone waves, Whistler waves, chorus emissions, interact with your electronics in ways that are not simply ballistic. They can induce currents. They can cause electrostatic discharge events. They can couple energy into internal circuits in ways that your radiation hardening was not designed to address. The plasma torus is not the most lethal region in the Jovian system. The inner radiation belt is, but the plasma torus is unavoidable on the trajectory to anywhere interesting. Io orbits at the inner edge of it. Europa orbits just outside it. Ganymede sits at the boundary between the inner and outer radiation belts. Every destination of scientific interest in the Jovian system sits inside, adjacent to, or surrounded by some component of this feedback system. There is no clean path. There is no quiet route.
Every trajectory to Jupiter's moons passes through material that Io has put there, energized by Jupiter, sustained by the orbital mechanics of a system that has been operating this way for 4 billion years. Io does not know it is doing this. Io does not know anything. It is a moon. It erupts because the physics of tidal dissipation dictates that it must. Jupiter accelerates the resulting ions because the physics of co-rotating magnetospheres dictates that it must. The outcome, a hostile radiation environment that destroys electronics, is not a feature, it is not a design. It is simply the state that 4 billion years of unchecked physical processes have converged upon. That is not reassuring. It is, if anything, less reassuring. Intention can be negotiated with. Physics cannot.
We have now described the system completely. We have described the magnetic cage, the magnetosphere that extends 20,000 times more energetically than Earth's, trapping everything that enters it in a jurisdiction from which there is no appeal. We have described the particle accelerator, the radiation belts that operate continuously on the rotational energy of a gas giant, producing electrons at relativistic velocities in quantities and at energies that have no terrestrial analog. We have described digital psychosis, the systematic corruption of silicon memory and logic under extreme radiation dose, the conversion of a functioning instrument into a device that returns incorrect outputs with full confidence, the probe that lies because lying is all it has left to do. We have described the vanishing signal, the noise floor generated by synchrotron emission, the plasma dispersion that corrupts coherence, the censorship mechanism that a magnetosphere imposes on any information attempting to leave it. We have described the lead shield fallacy, the engineering truth that shielding is delay, not protection, that every kilogram of protection is borrowed time against an inevitable total dose, that the endpoint is destruction and the only variable is the schedule. We have described Io's volcanic ghost, the moon that cannot stop erupting, the plasma torus it continuously feeds, the feedback loop that makes the Jovian radiation environment self-sustaining and self-reinforcing. The conclusion is simple. Jupiter is a forbidden zone for information. Not forbidden by decree, not forbidden in the danger in the colloquial sense, forbidden in the thermodynamic sense, forbidden because the conditions there are fundamentally incompatible with the structures that store and transmit information. The electronic logic gate is a structure that relies on deterministic electron behavior. The Jovian radiation environment makes electron behavior non-deterministic. The mismatch is total. The outcome is fixed. Every probe we have sent to Jupiter has been sent to die. We knew this. We sent them anyway, and correctly so. The data returned before death was worth the expenditure. Galileo returned 8 years of orbital science before its deliberate disposal into Jupiter's atmosphere in 2003. Juno continues to return data, its vault degrading increment by increment, its mission lifetime carved out of a radiation budget that is always being spent. The New Horizons spacecraft passed through the Jovian system in 2007 for a gravity assist, acquiring 700 observations before retreating to the outer solar system. It did not linger. It had other destinations. Future missions, Europa Clipper, JUICE, are being designed with even more sophisticated radiation hardening, with careful orbit selection, with extensive modeling of the radiation environment to minimize exposure. These are intelligent engineering responses to a known constraint. They will work. They will extend mission lifetimes. They will improve the quality and quantity of return data. They will not solve the fundamental problem. The fundamental problem is that Jupiter is not a place where human information technology can operate indefinitely. It is a place where human information technology can operate temporarily, with increasing degradation, until the accumulated dose crosses the failure threshold and the last coherent signal is transmitted and the probe falls silent. What remains after the last signal is not the probe. The probe continues to exist as a physical object, orbiting, falling, eventually entering the atmosphere or impacting a surface. But the probe as an information processing system has ceased. The memory that held the science data is randomized. The CPU that processed it is corrupted. The transmitter that relayed it to Earth has failed. What remains is a mass of degraded silicon and corroded metal, drifting in a magnetic field that has finished with it. This is the black box. Not in the aircraft sense, not a hardened recorder that preserves information through catastrophe. The opposite, a region in which information cannot be preserved, a system that converts structured data into white noise, a place where everything we try to know is replaced by static, where every instrument we send returns corrupted data or no data, where our capacity for understanding is constrained not by the questions we ask, but by the medium through which the answers must pass. Jupiter does not have answers it is withholding. Jupiter has no relationship to the concept of information at all. It simply exists, enormous and indifferent, operating according to physical laws that were in place long before silicon was first purified, long before the concept of a computer was articulated, long before any entity in this solar system had the capacity to wonder about the nature of the place it inhabits. The radiation belts were full before we arrived. They will be full after we are gone. The Io plasma torus was glowing in ultraviolet for 4 billion years before the first human eyes opened. The magnetic field lines were trapping electrons and accelerating them to relativistic speeds before the Earth had finished forming. We entered this system briefly. We transmitted what we could. The static consumed the rest. The channel is closed. This has been Gideon, Black Box.